Hello and welcome. Thank you for checking out my channel. In this channel, I'll discuss various computing technology such as Linux, Docker, Kubernetes, Windows, and other topics of interest. To get started, though, my goal is to help audience, especially those who are primarily Windows developers or infrastructure professionals who haven't used these new open source technologies, to set up their Windows 10 environment so they can install and learn those new technologies. And that is exactly what we do today. We will walk through the process of setting up a Windows 10 environment, and then we install Linux, Docker, and Kubernetes. So by end of this presentation, we will have an environment which runs Kubernetes with a single node cluster on top of Docker and Linux. In the future presentation, I will introduce you to Micro KS8 for setting up lightweight Kubernetes suited for workstations, edge, and IoT use cases. That will give us more flexibility to have more than one node, and also allows us to enable or disable the features that we need from Kubernetes. We may not need all those features in especially environment which don't have a lot of hardware resources installed. And following that, for those who want to set up a truly scale-out Kubernetes cluster, we will walk through the process of setting up a few Linux VMs, and then we'll network them together through NAS. So we'll have a private network set up amongst them so they can talk to each other. And once that's set up, we will install Docker Kubernetes from scratch, and we will have a truly scaled-out multi-node Kubernetes cluster. Longer term, I would like to deep dive into Kubernetes architecture and operation. So before getting into how to install those components on top of Windows 10, I want to talk a little bit about Windows Subsystem for Linux, or WSL for short. That is the technology that allows us to run Linux natively on top of Windows. Prior to WSL and during the Windows NT through Windows 2008 timeframe, Microsoft provided a Unix subsystem known as Subsystem for Unix-Based Application, or SUA for short. It provided a Unix-like environment on top of Windows. And the way it worked was customers would bring in their Unix-based application, recompile them with the help of SUA, and run them on top of Windows. Again, that was an emulated environment, not a true Unix environment. In recent times, Microsoft provided Windows Subsystem for Linux, again, another integration layer to run Linux. In version 1, there was no Linux actually involved. There was a translation layer that when the commands were run from WSL command line, those commands would run through a translation layer. And translation layer would call equivalent Windows APIs and would satisfy those calls. So there was no truly truly Linux environment. There was just an emulated environment. With WSL2, that architecture completely changed. Now, instead of that translation layer, there's actually a hypervisor layer. So once we start WSL command line, it actually loads through a hypervisor. It loads a very lightweight VM. It's very, very lightweight. It only takes 1 or 2 seconds to load, and that is truly unnoticeable. And that is the environment that we will be using today. So specifically today, we will install new Windows terminal. That is a terminal that you can run all kinds of shells, such as DOS, PowerShell, and Linux Bash shell inside that terminal. We will enable WSL2, and we will install Ubuntu as our Linux distribution. We will discuss VS Code, if you haven't installed it already, how to install it and what components we need to run commands from VS Code directly inside Linux. We will install Docker for Windows, and this version of Docker provides an option that allows us to run Kubernetes. So that will, when we enable that option, Kubernetes actually sets up automatically a Kubernetes environment with a single node. As far as prerequisite, we really need a Windows 10 Home or Pro version, but the version has to be 2004. And I will show you how to check your Windows version. We need about 8 gigs of RAM. You can go less than that if you plan not to run Kubernetes on top of that. So I would say 8 gigs of RAM gives us optimal environment for that. So I put together all this installation requirements and sequence together in a Word document. I will provide that as part of this course. Let's go to that document and start installing stuff. Okay, so let's go through the installation sequence and requirements. So the first one is install Windows Terminal. So we need to go to the Windows Store. So click on Windows Store and search for Terminal. Sorry. And select the first one, Windows Terminal. Click on that and click Install. So Terminal is installed. Now, once you just click on Launch, and it will start this, the terminal. As you can see, it looks like any other terminal that you used before, except you will see this down arrow. And now it shows you all the scripts the shells that are already installed, such as PowerShell, Command Prompt, which is basically DOS, and Azure. I'm using Azure. So these are the shells that are already installed. Now, once we install WSL and install Linux, we will also see all the installations that we've done from Linux over here. So that's as far as Windows Terminal is concerned. Let's head back to our list again and continue from there. Now that we installed Windows Terminal, we can check this off and go to the next step, which is ensuring that we have Windows 10 version 2004 or later. This is important, otherwise the WSL 2 will not work. So in order to check that, click on the Windows button on the keyboard and the letter R. So again, Windows button and letter R, that will bring up the Run dialog box, and then type in WinVer, that is Windows version, WINVER, click on that, and that will show us the version of the Windows that we have. So let's just zoom on it. And as you can see, it says the version is 2004. So I'm good to go. So, but you want to make sure that you have that installed. If not, you need to install at least 2004 version. At the time of recording, 2004 was the latest version of Windows. Just want to make sure that you install that. Next step is we need to enable a couple of features. One is, of course, Windows Subsystem for Linux, and the other one is virtual machine platform. So virtual machine platform, again, is a subset of Hyper-V. That is the technology that enables us to load the Linux VM into the Windows. So in order to enable those technologies, just click on the Start button and type in feature, and you will see turn Windows features on or off. So click on that, scroll all the way down, and you should see Windows Subsystem for Linux. Check that, and also very important, you want to make sure that you have virtual machine platform also checked. Click on that, and it will enable that for us. And it will ask us to reboot. To make sure, I'm going to say yes, reboot the machine, and we'll continue after the reboot is completed. Okay, so the reboot just completed. So we can go back to Windows features. I want to make sure that these two are enabled. So just type feature. And you can see Windows Subsystem for Linux and virtual machine, they're both enabled. Great. So let's just check those off. And the next step is to actually install a version of Linux from Windows Store. So go back to Windows Store and type Linux and click Ubuntu, the first one, and click install. I'm going to pause it for a little bit. Okay, Ubuntu was downloaded. Now we click on launch, and then it starts a bash window. That's Ubuntu bash. And then it starts configuring a couple of things. And then we need to create a new user. You can create any user you want and put in the password. Okay, Ubuntu now is installed on our machine, but before I start using it, there's a couple of steps that we need to take in order to make it work with WSL. So let's just check that off. The first thing is we need to update the kernel, the Windows kernel for WSL2. And I provided a link here. I already downloaded that into my machine. So that's done. The other thing that we need to, the next step is to set the WSL version to version 2. If you recall, there are two versions of WSL, 1 and 2. So this command will set our default to version 2. So this is actually good because if you're currently using WSL 1 and you want to switch back and forth, that will allow you. But we want to set our default to version 2. So open a terminal and run that command. And you can see this a little bit confusing. I think it doesn't tell you it worked. So if you see this message, it actually worked. If you get an error which says the set command was not found or something similar to that, it means that you're still on WSL1 and your machine is not set up correctly. So you either need to make sure that you're running Windows version 2004, or you want to make sure that you run the patch and updated the kernel, the Windows kernel. And then the next thing is we can see what version or what distributions of Linux we have. So right now we just installed Ubuntu, which is our default distro. But you can install other distro if you want. You can go to Windows Store. There are multiple other versions of Linux. If you want to install some of those, that's fine. The next thing that we need to do is we need to set our default distribution, in this case, Ubuntu, to use WSL2. So we copy and paste that. Oops. So it went very quickly because I already had set that to version 2. In your case, if you're doing it for the first time, it may take a little bit of a while to do that. But once that's done, then we can actually do some testing here. So let's just maximize that. And I do Control L, that will clear the screen. This works both in PowerShell and in Linux bash. So if you just type WSL, it will install, actually starts a new bash. So this is, we are actually running now in Ubuntu. As you can see, the command actually, the text actually changed from, so that's PowerShell. Now we have entered bash. So one thing we can do is check what version of Linux we have, and we do cat proc version. So let me explain. Cat, if you are not familiar with Linux, cat basically displays the content of the file. In this case, is version, which is under proc/proc. So if you do that, then it will show us the version of Linux. This is version 4.19128 at the time of recording this. And then it's actually, you see, it's Microsoft. So Microsoft maintained this particular version of Ubuntu that runs on Windows. The other thing that we can do is, if you do ls mnt, that is the mount folder. If you do that, so in Linux, when you mount, like Windows, you can share directories and folders between different installations of Windows or Linux. And usually, by default or by convention, they mount it under /mnt, but it doesn't have to be. But in this case, WSL actually mount the C drive. As you can see, there's a C here. That's our C drive on Windows. So if I do ls, so I need to do sudo, which is elevated privilege because I'm not going to access something on the mount, and do a C folder. So I need to put in my password. Kind of like in Windows, ls, forgot the ls. So this shows in my C folder. So as you can see, I'm able to see my files from Linux. So I can actually make changes if I need to. That works pretty fine. The other neat thing that we can do, we can actually run Windows applications, some Windows application from Linux. So if I do, for instance, Explorer, it launches Explorer. So from Bash, I can check out my file system on Windows if I need to. I can also do things such as notepad.exe, and it actually opens Notepad. So if I want to use Notepad on Linux, I'll be able to do that. I can modify my files in Notepad. So there's a ton of more things that we can do, but obviously I want to make this very short. So now we have Ubuntu installed. Let's just exit from Ubuntu, and we are back to PowerShell. One more thing that I want to show you is you can actually, if you go to the Explorer and type //WSL and $, it actually shows you all the folders for the Linux distribution that we installed. So right now we have installed Ubuntu. If I double click on that, I see the file system in Ubuntu. A word of caution, right now, you must not make any changes to the files from Windows on the Unix system, because it doesn't do the synchronization correctly. So don't do that. Don't make any changes, but you can actually take a look if you just want to see, look at the file system on Linux. You can do that from Windows, but don't make any changes. Okay, so let's start. So far we've installed Terminal, we installed Ubuntu, we configured that, make sure it runs on WSL2. Now let's go back to our command or installation guide and see what we need to do next. Okay, we are back inside the installation guide. Next step is to install Visual Studio Code. I provided a link here. Go ahead and install that. I've already installed it, so I'm not going to go through the process again. And also, once you install Visual Studio Code, you also make sure that you install the remote dev extension pack. And there's a link here below. What it does, it allows Visual Studio Code from Windows to connect to the Ubuntu or any other distribution that you use, and use the folder structure and use your file or your scripts which is installed on the Ubuntu side. So I'm going to show you how that actually works. Let's go back to command line and go back to WSL. So we are now in Ubuntu Bash shell, and if I type code dot, So code stands for Visual Studio Code, the shortcut for that, and dot means current folder. So I'm telling Visual Studio Code to open and use the current folder structure. So when I do that, it opens Visual Studio Code, and you will see that there's a file here. It's automatically show me that file. So I can click on that and use it if I need to. Again, also down there, you will see that this is the Linux command prompt. So again, it shows that we are inside Ubuntu. Also down below here, let me make that a little bit bigger. You'll see it says WSL Ubuntu. So it's another proof that we are actually connected now from Visual Studio Code, which is running, itself is running on Windows. We are accessing the file structure inside Ubuntu. So if I run any command from here, then it will show me the, for instance, ls of file system. What files do I have on this folder? And it's the same one that you can see up here. One thing to note is when you open Visual Studio Code for the first time, you may not be a terminal below here. No worries. Just go to the terminal up here and click New Terminal, and it opens the terminal for you. Usually when I run type a command here and press F8, Visual Studio Code runs that inside the terminal below. But this is not the way it works when you're remote. But it's easily, you can set your key binding to do that. To do that, you click Control K and Control S. That will open the keyboard shortcut dialog. And then you search for terminal run selected. Let me make that a little bit bigger. So you just type in terminal run selected. Let's do that. So this is a command we want. So we want to bind it to a key. And then I press F key on my keyboard and press enter. So now the key binding is set up. You can see key binding F8. So if I close this and do another ls and now F8, you will see that now the results are shown below here. You can do another thing, I don't know, IP ADR. I want to look at the network information on Ubuntu. When I do that, then you will see that it shows all the network information. This is the loopback, and this is the actual IP address. So this is as far as installing Visual Studio Code and configure it to run remotely on Ubuntu. So let's go back to the document and look at the next step. Next step is to install Docker. Docker is required to manage our containers and also is required for installing Kubernetes, or one of the requirements for Kubernetes. I provide a link here. I already downloaded that on my machine, so I'm going to run that installation. And we want to make sure that we enable WSL2, and also if we can add a shortcut to the desktop. I press OK. So it's going to take a little bit to install that. I'm going to pause that and continue afterwards. Okay, Kubernetes is now installed. If you click on the tray here and click on this icon, this is the Docker icon. And then you see a bunch of options. It's restarting it, learning more, looking at documentation and so on. But settings is the one that we want to take a look at for now. So these are first the general settings. And one thing we want to make sure is that WSL2 engine is turned on. So if you have followed the instructions, you should hopefully, this is already checked for you. Under resources, you can look at the proxy and network. They are pre-configured for you. You don't have to worry about those. And the WSL integration, you want to make sure that this is checked, enable integration with my default WSL distro. And then to show you all the distribution, Linux distribution that you have installed on your machine. In this case, we only have Ubuntu, so we're going to enable that. So Docker is going to use this Ubuntu for all this operation. So I say apply and restart. Okay, that's now done. Next thing is to configure Kubernetes. And then we can click on Enable Kubernetes because we want to use Kubernetes with Docker for our testing purposes. So click on Apply and Restart. And it's going to take a couple of minutes. I'm going to pause and then we continue. Okay, Kubernetes is now configured. Now we have a brand new cluster that we can go and play with. So a couple of things to notice. First of all, you can always disable Kubernetes if it's taking too much resources or you're done testing. You can always come here and uncheck this. I will delete Kubernetes from your machine. The other thing is if something goes wrong when you're testing with your cluster, you can always come back here and reset. So it will recreate the cluster for you, which is nice. Okay, let's go to the command line and Visual Studio Code so I can show you some basic stuff about our cluster. So I prepared some information, some command line connecting to our Kubernetes to kind of learn a little bit about our cluster. I will cover Kubernetes in detail in the future demonstration, but for now, I have some simple command that we can go through it. First one is you notice that there's kubectl in front of all these commands, and that's the command line utility that we need to use in order to interact with our cluster. So the first one is kubectl cluster info, getting some information from our cluster. You like press F8. You'll see that the information is shown below. So first one is the master. So Kubernetes consists of one or more master, depending on how scale out your Kubernetes cluster should be, but at least one master, and then one or 0 or more nodes. So in this case, master is the only one that we have, so it plays both the master role and other nodes roles as well. And then below that, some information about the kube DNS, which is basically manages the DNS settings on the cluster. Next command is kubectl get nodes. So you want to get some information about our nodes. So press F8, and you will see the results below. You'll see we only have one node, and that node is Docker desktop, so it's one of the distro that we used. The role is master and the version number. Next step is to deploy a container for testing. So let's just go that together. So kubectl create deployments. So you're telling Kubernetes we want to deploy a pod or more to the cluster. We name that, so that's the name of the deployment. We can name it whatever we want. I just call it Hello World. Next one is where do we get the image from? So we need to somehow deploy a container into the cluster. So we need to specify where the image is coming from. So image equal to, and then this part, which is basically, this is the container repository running on Google. So this is Google's repository of containers. The next one is what is the name of the container? So that's hello app, hello dash that app, and then this is the version. So we are deploying a container from Google called Hello World version 1. We want to deploy that in our cluster. So we press F8, and then down below here we'll see that deployment Hello World was created. So to double check that deployment, we kubectl get deployments, press F8, and we will see information about our deployment. That's the name of it, and it's already ready, so it's ready to go. And this is the age when it was created, it was just 15 seconds ago. And the next one is we want to take a look at pods. So pods, if you're not familiar with that phrase, is basically containers. That's a lingo that Kubernetes uses in order to identify and work with containers. A pod can consist of one or more containers. So usually for a loosely coupled application, there's only one container in the pod, but there are situations where there are dependency between pods. So we can include those. For instance, an application and database itself, or the cache or a database that needs to be part of the application itself. So we can have two containers and deploy them in a single pod. So let's execute that. And below here, now we'll have information about our pod. This is the name of the pod, hello world, dash and some GUI that Kubernetes selected for us. Ready, one out of one, so we only had one, so it's ready to go. Status is running, so it's good. Again, the age when it was created. So this is the IP address of the pod, and the node which was created, which was on our master. So that's as far as information, as far as pods are concerned. Next thing is we need to, so that pod is there, it's sitting there, is running, but it's not really connected to anything. Next, we need to expose a service so we can connect and interact with that pod. So this is how we do it. kubectl expose deployment. So we name it whatever we want, maybe just name it hello world, like our pod and our deployment. So we are creating a service called hello world. -- port and the port number that we choose, that is the port number of the service that is running inside the cluster. So that this is not visible outside the cluster. It's only for internal. And -- target port and the port number, that is the container, that's what port the service is running on inside that container. And then -- type equals node port. This is, when we say specify node port, that will create a port that we can interact with the service from outside our cluster. So in this case, we need to specify that if we want to work with it outside the cluster, we have to specify -- type equal to node port, and that will create a port for us so we can actually connect to the service from outside world. So let's run that. And then below here, it says service hello world is exposed. So to verify that, you can run kubectl get services. Yeah, let's execute that. And then we'll see two services. Below, the Kubernetes one is the one that Kubernetes already created. That's not our concern. This is our service that we just deployed. You can see the name of the service, and the type is node port. That's the cluster IP address. Again, that cluster IP is only visible from inside the cluster, and it's actually load balanced. So you can, the services that are running inside the cluster, they can use this cluster in order to talk to that service. But in this, just keep in mind, in this installation of Kubernetes that Docker created for us, the networking is not complete, so we are not able to access that node cluster IP from inside cluster, so we need to use the node port. So if you come over here, so that 800, that's the service IP address internally, and also this is the node port. So this is the port that we're going to use in order to talk to our service. So if you, let's just do testing. Let me just change this IP address. So let's walk through this. So right now we are outside the cluster. We want to actually test our service from outside the cluster. So curl, and then the IP address. So this is running on we can access actually through our local host. So Docker and Kubernetes provides a proxy that we can actually run from our desktop. So that would be the local host. And 31813, that's a node port number. So that's a port number we can connect to. So let's run that. And now we'll see that we get result. This result is coming from inside our container, our pod. So this is hello world. So basically this is a sample application that specifies a message. So this is our pod name, and there's some information about that. So this is a very simple application. service that is running, and we get the result. So this is how we connect from the port from outside the cluster to the cluster using node port. Now, one thing we can do is we can also actually connect to the pod itself. Let me just specify a pod name. So let's just go through this. We can actually shell to our pod. So kubectl exec /-it. This is our pod name. So we are saying Kubernetes, we want to connect to our pod. And what we are going to run, we want to sh, basically, we want to shell to our pod that we just created. So press F8. And below here, you'll see now we have a different prompt. So we are actually inside our pod. So if I say something like hostname, and we'll see this is indeed we are inside our pod. That's our pod name. So very cool. Cool. If you want to troubleshoot your pod, you can always connect to it through kubectl exec. So let's just exit out of this. And we will cover this in a lot more detail in the future. Next thing, and this is really the beauty of having Kubernetes running, is let's say we had one pod running, but that's not enough for us. Well, we need to increase the number of pods because we have more users. Now we have to be able to satisfy the new demand. So we can actually scale. So kubectl scale, basically we want to either scale up or down. Replicas, how many replicas we want? 2. So we're actually scaling up. In this case, we only had one replica or one pod. Now we can say, okay, we need to scale it up. And then what deployment? We specify the deployment, which is hello world. So we were telling Kubernetes, please add another pod for us, configure another pod for us. So when you run that, we'll see that successful message, deployment, ASP, hello world, scaled. So to verify that, let's look at our pods again, kubectl get pods, run that. And now we'll see we have 2 pods running. So we easily, with just a command, we scaled up our cluster. So great. Next, we just summarize what we covered today, and then we'll discuss what we'll do in the upcoming demonstrations. Let's summarize what we did today. Overall, in this presentation, we set up our workstation to support Linux, Docker, and Kubernetes. We briefly discussed WSL2 architecture. We checked our version 10 to ensure it is 2004 or later. We installed new Windows terminal. We enabled Windows features, Windows Subsystem for Linux, and virtual machine platform. We installed Ubuntu distro for Windows 10. We installed kernel patch for WSL2. We set the default WSL version to version 2. We also set Ubuntu to use WSL2. We installed Docker and configured it to integrate with WSL2. We enabled Kubernetes options that come with Docker and tested our cluster. And finally, thank you very much for your time. I hope that you found this video useful. If so, please give it a like and share and subscribe. I also hope you will join me in this journey to learn more about Linux, Docker, Kubernetes, and other topics of interest. Thank you again, and please take care until we meet again.